Hello and welcome to another video. My name is Gareth Williams and today I would like to demonstrate how to configure OSPF authentication. There are two types of authentication, clear text and MD5 hashing, and I'm going to demonstrate how to do both. There are two ways on how to configure authentication. One is under the OSPF process and the other is under the interface. In this example I'm going to configure authentication under the interface. All I have done so far is configured these IP addresses that you see here. So we've got the 12.0/30 network, the 13.0/30, and these loopbacks with the /24 in areas 2 and 3, and they're connected to area 0. The reason why I'm configuring under the interface is because if I was configuring the authentication under the OSPF process, then all routers in that area will need to be configured for that type of authentication. So for example, if I was under the OSPF process in R1 and I set up for MD5 hashing, then both routers R2 and R3 will need to be configured for that type of authentication. Since I'm going to be configuring them under the interface level, I can specify what type of authentication I would like to use. So between R1 and R2 I'm going to be using MD5, and between R1 and R3 I'm going to be using clear text. Like I said, all I've done so far is configure the IP addresses. There is no routing protocols at the moment, so we'll go ahead and configure OSPF first. So I'll set my router ID and then I will advertise my networks. So this will be a wildcard mask of 3 in area 0 and 13. Hop on over to R2, configure T, router OSPF1, router 2.2.2, network 192.168.12.00.0.3, area 0. Okay, so that's come up. We'll do these loopbacks as well. This is area 2. 2.2.2 and 3.3.3, and up on over to R3 and config T router OSPF1 router ID 3.3.3 and net 192.168.13.0/3 in area 0, and that's my adjacency. This is area 3, 5.5.5.5 and 6.6.6. Okay, so if I go to R1 and let's have a look at the routing table. Okay, so we see 1, 2, 3, 4, 5, 6. Okay, yeah, so that's good. But if you see here, there /32 addresses. Okay, so that's one. So that's that network there. That's on R2. So let's have a look at that interface quickly. Show INTLO1. Okay, it's actually configured as a /24. Okay, now there is a way to get this to appear correctly. If I was to do, let's just have a look at the interfaces. Okay, so if I do an int range LO123 and then I go IP OSPF, what's the command? Network point to point. and I'll do it over here as well. So int range L0426 IP OSPF net point to point. And let's have a look at this again. See? Now they're /24s. One thing further I want to do with these loopbacks is at the moment, because I use the network command, let's say for example these loopbacks are actually fast Ethernet devices connected to different networks, and I want to advertise those networks. Now the problem that we've got is that hello packets are also being sent out of that, out of those interfaces. And let's say somebody brings along a rogue router, plugs it in, does all the configuration. They can also form an adjacency if the hello packet parameters match. Now we don't want that, so again I'm going to stop hello packets being sent out of those interfaces, but at the same time those networks will still be advertised. Okay, so I'll go under OSPF1 and passive interface default. Okay, so the passive interface stops hello packets. So the passive interface default command stops hello packets being sent out of all interfaces. So the neighbor adjacency has just gone down. Okay, so if I do no passive interface 00/0, okay, so so that's saying, you know, no passive interface on that particular interface, so hello packets are being sent out of serial 0/0, and we'll do the same over here. So it's under the OSPF process. Passive interface default and no passive S0/0. Okay, and we'll just confirm that, make sure we can see all the routes. Yep, we'll do a quick ping, I think. Yep, so that's from R3 to R2. Let's have a look here. Ping the address 6666. Okay, so that's it for that. Next, we will configure the authentication. We'll do the MD5 hashing first. So, like I said, we need to go under the interface. Really simple. IP OSPF authentication message digest. Now if we also have a look at the OSPF neighbor, we should see the neighbor to 2222. The dead timer is not being reset. So once that dead timer expires, the adjacency will go down. Okay, so what we could also do is do an IP OSPF message digest key, give it a key number, MD5, and the password. In this case I'll just call it Cisco. Okay, see that the dead timer is expired to that neighbor on that interface, went from full to down. Okay, so let's go to R2 and do it there. Under the interface again, IP OSPF authentication message digest, and then IP OSPF message digest key 1 MD5 and Cisco. If I do show IP OSPF neighbor, no neighbors yet. There we go. So neighbor 1111 on serial, that from loading to full, and it's complete. There's one thing I want to mention here quickly, is if I do an IP OSPF, yeah, when I was first doing this, I'd always, for the MD5, I would always go under that, and I'll be troubleshooting for ages, like, why isn't this working? But that authentication key is only used for clear text. The message digest is for is when you configured it for the encryption. So I'll demonstrate now, actually. Okay, so this is the interface for the other connection to R3. So it's OSPF Authentication again. Now what I can actually do, I can actually type in null or hit enter and carriage return. Both do exactly the same thing, and this is for the clear text. So hit enter that. Do show IP OSPF neighbor. Okay, we should see the dead timer to 3333 go down. Eventually it will expire. I'll set the password authentication -key, and I'll call this Cisco 123. Then, okay, see the dead time is expired there again. I'll hop on over to R3, go under this interface, and IP OSPF authentication, enter. IP OSPF authentication -key, and it was Cisco 123. And there we go. Our neighbor adjacency is formed. Yep. One cool command that I've used before in the past, if you want to see how long the neighbor adjacencies have been up, I mean, what you could do is, if I do a show IP OSPF neighbor detail, I mean, somewhere in there, yeah, neighbor is up for 31 seconds, neighbor is up for 2 minutes 45. What I tend to do is just show IP OSPF neighbor detail -include up. Yeah, I mean, that's a well, I use that quite a lot anyway. If I want to see how long a neighbor has been up for. Okay, so that's about it really. So here is using clear text, and here is using encryption. I mean, well, what I could actually do is we can run a Wireshark capture now. Okay, let me have a think now. I'll move this out the way, because I think that will screw stuff up. Okay, so I'm going to start my capturing on... Let me have a think now. Start capturing R1. Yeah. This is right, yeah, 0. Okay, yeah, that'll do. And then if I start Wireshark, I'll wait for it to load. Okay, I'm looking for those hello packets there. Okay, so, and let me just stop this now. Stop Wireshark capture. Okay, so if we have a look at the hello packet, hello packet, I mean, this stuff here is pretty cool. I mean, that's the neighbor. Okay, I take it. Source and destination. Yeah, so this is from R3's perspective. That is the neighbor, the router ID. If you notice here, there isn't a backup there's no designated router and the backup designated router. That's because they're on a point-to-point link. So there's no DR/BDR election. If we have a look here, yeah, see this here? Authentication type simple password, authentication data Cisco 1, 2, 3. So yeah, well, that's the hello interval, and that's the dead timer. I mean, yeah, I mean, that's the problem with using clear text. You know, you can put a sniffer on it and get the password. Okay, now then let's have a look at the other side. Quit without saving. Okay then, so start capture. Okay. Okay, yeah, there's some hello packets there. Let me just stop this. Header. Yeah, see? Authentication data, blah blah blah. It's just that. So again, there's no there will be no DR/BDR election process. That's the neighbor, and that's about it, really. Yep, thank you for watching.